I'm a PhD student in the camera culture group here at the MIT Media Lab. And what I'm going to talk to you today is about designing superpowers with computational perception. And so the idea here is that maybe we can combine computers with sensors to be able to see things that we normally can't see. So I'm in the camera culture group, and our PI is Ramesh Rasker, and something he likes to say is making the invisible visible. And we think we can do that by combining some of our work with computers, and some of our sensors with computers. So I'll do a quick background, and I'm a PhD student. And one of the things I worked on for my master's was called iSelfie. And this is probably the closest thing to AR or near-eye displays. But I won't talk about that at all today. What I'm going to talk about is a combination of computational imaging, perception, and some near-eye displays to enable new kinds of things that we can do with our devices. And in particular, I think that we can imbue ourselves with AR superpowers. We can give ourselves magical abilities like Superman, have X-ray vision, we can see through walls, see around corners, or perhaps even be able to transmit our experiences moving through space to other people. And I'll break this down by kind of throwing a couple different technologies into a triangle here. So on one end, we have sensors like cameras and microphones. These are common sensors you might find in your smartphone. Computation, this is our computers, our databases, network communication. And built on top of these things are technologies and algorithms that we might call AI. And what do I mean by AI? This could be detection, classification, prediction, or reasoning. And the idea is that you can combine a couple of these different aspects and get something that sort of is human-like. But what's really important is how do we interface these kinds of things with our own understanding of the world? So how does the user interface or the interaction actually work in between these different areas? And I imagine a future AR device that interfaces perhaps with our own perception systems. And if we could do this, we could leverage the advantages of the sensors that we have access to today with the kind of computation we have to allow us to see things we normally couldn't. So some example superpowers. Psychic navigation. So could I walk through a space and communicate to someone else what it was like to move through that space? But not in sort of a traditional way. Could I actually give you an intuitive understanding of how it was to move through that space? Another thing you might want to do is see around corners. Could I allow you to walk up to a corner and actually see what's around the other side? So, when I think of psychic navigation, what we're really trying to do is leverage the sensors that we have access to. This allows us to do things like build 3D models of the environment. But maybe we don't actually need to build a 3D model to really understand the environment. Maybe instead, we can kind of go low tech, and we can just record a video and then train a privacy-preserving neural network to then classify the directions as we move through this space. And what this might allow us to do is train an extremely memory-efficient representation of moving through the space, and then later on, someone could walk through that same path and get instructions on how to follow the path that I did. So what does this actually mean? This means that I can walk through and provide a path and then communicate it to someone else without actually giving them an image or giving them a visual path. That they sort of have to go through the space and record an image to be able to uncover their way through the path. So it's kind of like thinking about each percept or each image in that space as unlocking the next direction as I move through it. You can't just look into the code or look into the representation that I've shared with you and understand what the path was. But perhaps the most superpower-like ability is seeing around corners. So the group that I'm part of, and my PI Ramesh Rasker, a few years ago, thought about how could you see around corners if you leveraged femtophotography. So using extremely precise imaging that is able to measure how long it takes for a pulse of light to travel through the scene. And if you're able to use this information, they showed that you could recover 3D models of objects around the scene. You essentially turn the walls and objects into mirrors. And this is really cool, and it has amazing applications. But something we've been thinking about recently is how could we do this with just a regular camera? Maybe we don't need to have the kind of time resolution that we needed for before. So this could allow smaller form factors and less heavy computation as was needed. So a good example of this was work done by my colleagues in the lab, where we trained a neural network to be able to do reconstruction and localization of objects around the scene, and I'll show kind of an animation. And what you're looking at here is the predicted location of objects around a corner on the bottom left, and what's actually input to the model. So this is, if you were to tie this to AR, this would be what the cameras on your device would see is on the top right. So you don't see actually very much of a change, but the information is there, and that's the key. That the cameras actually are seeing very small cues that allow them to localize objects around the corner. And here's a kind of an extreme example. In this case, the camera is pointed at the images on the left, and then you can see the ground truth image of a training data image in the middle, and then a reconstruction on the right. And this is kind of cheating, but it gives you an idea of that there is some kind of differentiating information on these images on the left. So we actually have a camera that's looking, this sort of grayscale camera, and then it's using subtle changes in those images to make the reconstruction on the right. And so this, I think, is really suggesting that we could imagine giving ourselves superpowers if we could combine this with AR. So I'm going to go back to the original triangle and think about how can we combine these different technologies together. And in particular, how can we think about perception extension as we move forward? So that kind of covers it. I'd love to talk to you more about this, in particular, the work that we're working on now offline. And also, I'll say that there's a bunch of other cool projects in our group, and we're looking for postdocs. And so you can check that out on the Camera Culture webpage. Thank you.